Calculus students, welcome to section 7.3, three variable linear systems. Now, you've already worked with this a little bit in chapter 8 with matrices, and we are going to be applying matrices here too to solve these systems rather than algebraically because it's the easiest way. And really all we need today is an example video, right? Because you've worked with three variable linear systems in the past in algebra. We looked at them in chapter 8, and so we just need some examples. So what I'll be doing here is setting up matrices, and because you know how to solve those, but we'll talk about that, you know, in a very short manner. So let's take a look at problem number 21. And problem number 21, they are asking you to solve for X, Y, and Z. And I guess I didn't even write that. Solve for X, Y, and Z. Well, notice what we have is three equations with three variables. In matrix form, that would be a 3x4 matrix. We have three rows and we have an X column, a Y column, a Z column, and a solution column. Just wanted to make sure that you knew that you have to have an entry, a value in for each entry in your matrix, meaning that in the first equation, you would have a 2 in row 1, column 1, and it doesn't show any Y's, and so you would have 0 Y's. So your first row in your matrix would be 2, 0, 2, 2. In your second row, you have 0 Z's. And so you would have 5, 3, 0, 4. And in your last equation, you have 0 X's, right? And so you would put that, those coefficients and solutions into a 3x4 matrix. Ask for an RREF, and you would read those solutions for X, Y, and Z. Okay, this is like number 57 in your book because there weren't that many problems. So I made my own example. Find the equation of a circle that passes through these 3 points. When they would ask you that for a parabola, you could do that by matrices, but you also could do that by a quadratic regression. There is not a circle regression on your calculator, so matrices is the best way to go. Notice we would have the equation of a circle in general form if we had the D, the E, and the F. Okay, so notice we have three variables, we need three equations, and here's the work for that. So what happens then is we have an equation for associated with each one of these points. The points 4, 3, -2, -5, and 5, 2. Okay, so let's do this carefully. Notice that my X is 4 and my Y is 3. So wherever I see an X, I'm going to put in a 4. Wherever I see a Y, I am going to put in a 3. So 4x squared would be 16 plus 3 squared would be 9 plus this would be 4D plus this would be 3E, and we're always going to have plus F equals 0. There is the equation that's associated with the first point. -2, -5 would be 4 when I square the -2, 25 when I square the -5. I will have a -2D minus 5E plus F equals 0. Last point, X is 5, Y is 2. That would be 25 plus 4 plus 5D plus 2E plus F equals 0. Okay, so we have three equations and three variables. We just need this to be matrix ready. We need our first column to be the D's, our second column to be the E's, our third column to be the F, and this last column should be our solution column. So what we have to do to get this matrix ready is notice on the left-hand side of the equation, 16 plus 9 is 25. So I'm going to subtract a 25 from both sides. So my first equation is now 4D plus 3E plus F equals a negative 25. Let's do the same here. This is a positive 29. I'm going to subtract a 29 from both sides. I now have negative 2D minus 5E plus F equals a negative 29. In my last equation, notice I also have a 29. I will subtract that from both sides. I have 5D plus 2E plus F equals a negative 25, negative 29. My system of equations is now matrix ready to put in a 3x4 matrix, ask for an RREF, and solve for D, E, and F. And then my D would go here, E here, F here, and you have written the general equation for a circle that goes through these 3 points. Let's do problem number 70. I think I assigned problem number 69, which is like this problem, so that's why I'm doing this one. They ask you to find X, Y, and Z. And so, because I have 3 variables, I need 3 equations. Notice, first of all, that in the triangle, X plus Y plus Z equals 180. So there's my first equation, X plus Y plus Z equals 180. Notice that right here, that these two angles are called a linear pair, meaning that they add up to 180 also. So I'm going to write that relationship. X plus 1.5Z plus 3 equals 180. And I'm going to write that same relationship here. When I add up these two angles, they add to 180. So I have Y plus 1.5Z minus 11, minus 11 equals 180. Okay, now I have 3 equations, 3 variables. I just have to make sure these equations are matrix ready. I am going to circle the first equation because it is matrix ready. Okay, let's take a look at the second equation. So we're going to come on down here. I have 1x. I have 0 y's. I have 1.5z equals, and I'm going to subtract a 3 from both sides and get 177. The second equation is now matrix ready. The last equation, I have 0 x's plus 1y plus 1.5z, and I am going to add an 11 to both sides and have a 191. So next what you'll do, take the 3 circled equations, 3x4 matrix, RREF, and solve for X, Y, and Z. Have a good day.